name is Crissy, and I am from the Chattanooga Public Library. And today we have a very special guest with us. So, special guest, introduce yourself.
I'm Mr. Shober. I teach science at Brainerd High School.
Awesome. We're so excited to have you. And today for our STEM activity, we are going to be doing a baking experiment. So Mr. Shober is going to lead us in the program, and I'm going to do it. So we're going to go over our supplies and some instructions, and then by the end of the science experiment, you will have a baked good of some sort. Sound good?
Yeah.
Sound good? Yeah.
Okay, cool.
All right, so supplies, take one.
Okay, so the supplies that we're going to need for our baking experiment are 2 cups of all-purpose flour, 1 tablespoon of baking powder, not baking soda. They're different, and we'll talk about that in a minute. 1 tablespoon of granulated sugar, 1 teaspoon of salt, 6 tablespoons of unsalted butter. And if you don't have unsalted butter, that's okay. If you just have salted butter, then you'll just add less salt later on. And then last of all, we'll need 3/4 of a cup of whole milk. So the tools that we'll need are an oven, obviously, a baking sheet, some measuring spoons and measuring cups, a large mixing bowl to mix everything up, and a knife to cut the butter.
All right, sounds good. I think I have all of my supplies, so I'm ready to get going. So go gather yours, and we'll come back with some instructions. Yay!
Okay, so what we need to do is we're going to butter our baking sheet, and that will help our baked goods to not stick. So all you need to do, Crissy, is just unwrap your butter a little bit and kind of rub it all over the flat part of your baking sheet. Now you're going to take your butter and you're going to put it in the freezer, not the refrigerator. We want our butter to be really cold when we are making our baked items. So go ahead and put your butter in the freezer, and then when you're done with that, you can preheat your oven to 425 degrees.
Okay, let me run do that.
Okay, so we are going to actually make the same thing 3 different times, but we're going to do it a little bit different each time. And we're going to change one thing each time, and that's going to let us compare what effect that one thing has. So for our first trial, what you need to do is get your mixing bowl, and you're going to combine 2/3 of a cup of flour and 1 teaspoon of sugar and 1/2 teaspoon of salt in the mixing bowl. So I'll let you go ahead and get ready for that.
Flour, sugar, salt, and
it's 2/3 a cup of flour.
Okay. I've got a 1/3 cup, so I can just do that twice, right?
Exactly. In fact, that is exactly what you should do.
Okay. So, of flour. Here we go. So is it okay if I just have a heaping amount
your
like
measuring
this?
cup, if it's exactly full, that would be 1/3. So do you have more or less than a full cup right there, or full measuring cup?
Probably more.
Probably more, right? And so we don't want to use it like that because we'll get more flour than we really want. So what you can do is take your finger and just slide it straight across and knock off the extra flour. We'll have a nice, even, smooth top there. And that is exactly 1/3 of all-purpose flour. And now you can put that in your mixing bowl. And very good. And now do the exact same thing again. Scoop it up. Level it off. Perfect. And then add that into your mixing bowl.
All right.
All right, very good. We're done with flour for trial 1. So what you need to do now is do 1 teaspoon of sugar. And we're going to use the same kind of technique, even though it's a smaller little measuring spoon there. we don't want a heaping spoon. We want just one even rolled off spoon of sugar. Very good. Okay, now the next one is a little tricky. It is 1/3 teaspoon of salt. And most people don't have a 1/3 teaspoon measuring spoon. And so we're gonna have to kind of be a little, have to do a little trick here. So 1/3 is kind of in between 1/2 and 1/4, kind of like 3 is in between 2 and 4, right? So what we're going to do is we're going to start with 1/4 or 1/4 teaspoon, and that's a little bit less than 1/3. So go ahead and add 1/4 teaspoon of salt. Okay, now that's not quite enough though, right? So what we need to do is add a little bit more. Not even as, less than you just added, maybe like even a half as much as you just added.
Yep.
And go ahead and add that in. Okay, so that was not the most scientific we've ever done, but we got to make do with what we've got, right? And so that'll work for today. It's just salt, which is not like the most specific ingredient. And as long as we're pretty close on each trial, we'll be fine. Okay, so we are all got all of our ingredients. So what we need to do is kind of stir up what you've got there. Very good. Just get it kind of mixed together. But we've got more mixing to do. So what you're going to do now is you're going to go get your butter that's nice and cold from the freezer.
I'll go do that.
I'll be here.
Butter, frozen butter.
Okay, so take your butter and you want to chop off 2 tablespoons worth. And if your butter is still in the little wrapping paper kind of stuff that comes around it, that will usually have little markings on there to tell you, how much is 1 tablespoon, 2 tablespoons, and so on. And so what you can just do is you can kind of see where you need to chop it, and then just chop it off.
Ooh.
Okay, now we are going to need the rest of that butter later on, so go ahead and put the big block back in the freezer.
Done.
Okay, so next, we don't want to just stick our cube of butter in there. That's not going to do any good, right? That's going to be not a very well mixed treat. So we have 2 options here. If you have a box grater, you can use that to grate your butter into your bowl. Or if you don't have one, or even if you do and you don't feel like using it, just use your knife to chop the butter into small little slices, little chunks. They don't have tiny, but we don't want any like big chunks. We're thinking maybe like the size of a grain of rice is kind of the area we're shooting for. So you can go ahead and start chopping your butter and just go ahead and add it into the rest of your stuff. And Crissy is going to go ahead and do something that I mentioned that I didn't say, and that is we probably ought to take that paper off because paper doesn't taste very good and we don't want that in our baked item. So Crissy is going to start chopping now. These are also not, we're not baking any fingers here, so make sure you don't chop off your finger. So be careful, but you don't need to, don't take too much time.
Safety first in cooking and in science.
Yes. I would say safety should probably come first in just about every aspect of your life. I can't really think of a situation where safety is not the most important thing. I don't know. Maybe that's a conversation for another day. Anyways, we've got our butter chopped up and put into our mixing bowl there. And so we are ready to go to the next step, which is to add 1/4 of a cup of milk to our mix. And
does it matter what kind of milk, Junie?
It does matter. We need to use whole milk. And so what the difference between whole milk and skim milk and 2% milk and things like that is how much fat is still in there. And so if we don't have, if we were to use skim milk, we're not going to have the right amount of fat, which in science we call lipids. So you do want to make sure you are using whole milk. Whole milk, it basically has more fat in it than skim milk or 2% milk. And so if you were to use a different type of milk from whole milk, your end product would probably not taste quite like we want it to. But if you don't have any other options, you could try it, and then you could let us know how your final product ends up, and we'll, just count that in our science. So I think we're ready now to make some dough. So Crissy, what you need to do is use a spatula or a wooden spoon or something to mix up all of our mix there. In fact, if you wanted to use one of your measuring spoons, you could probably use that also. Okay, so Crissy, as you are mixing up our dough here, we do want to get everything mixed together and kind of evenly spread out. It's okay if there's still some clumps of butter. In fact, that's good to have like the little, tiny clumps of butter kind of spread around in there. But what we don't want to do is overwork it. We don't, because we want things to stay cold. So it should be starting to stick together into kind of like a Play-Doh-y kind of glob. And yes, I like what you're doing there with kind of cutting it a little bit and then smushing it back together. And that will help mix things up. Key here, ideally we want things to stay cold. And as we start working with it, it is going to warm up a little bit, which is fine. That's going to happen. There's no way around that. But, just to keep in mind, we're trying to... So let's go on to our next step. Okay, so once things are mixed together pretty good and it's kind of sticking together, kind of like a glob of Play-Doh, like I said, we are going to take it out, but not yet, because we need to get our surface ready before we take it out. So Crissy, what you can do is take some of your flour and you're just going to spread it on whatever surface you want to. Crissy has a nice wooden butcher block here to work on, and she's going to sprinkle some flour onto it. And what that flour is going to do is just help keep the dough from sticking to everything, like the board, hands. So once she's got a nice layer of flour there, what she's going to do is just go ahead and take the dough out of her mixing bowl. Very nice. Okay, then she's going to start kind of working it a little bit with her hands, just kind of smushing it together. And if it's still really sticky, she can add some more flour to it, and that will help keep her hands from getting all stuck to the dough and the dough kind of coming apart. So that's looking good. Now what she wants to do next, as she starts working it and kind of massaging it a little bit, is she wants to start folding it in half. And so you kind of fold it over on itself. Very good, and then kind of push down on that. All right, now what you're going to do is you're going to turn it 90 degrees, or, and you can turn it either way, it doesn't really matter. Beautiful, just like that. And now what you're going to do is the same exact thing. If you need to flatten it out a little bit more, you can, but you're going to fold it over on itself, just like you did before. All right, there's number 2. We do 5 times total. So we just did it twice, so we can turn it again and fold. That makes number 3. And it looks like it might be sticking a little bit, so it needs to add some more flour. Go for it. All right, there's number 3. And turn it again. Very good. And fold. Very good. And one more time. All right, on some flour, get it mixed. And there's number 5. Okay, good. So we are almost done with this trial. What you need to do now is you're going to use your hands again to kind of shape it into about a 1-inch thick layer. And if you're not sure how big an inch is about the same as 1 knuckle here on your finger. Or if you have really small hands, maybe you need to, borrow hands from someone who's got a little bit bigger hands. But generally about as thick as 1 knuckle length here. Okay, so if we were to cook this just as it is now, that's going to be one pretty big baked item. So what we might want to do is split it in half, and then kind of reshape those into kind of circular or square shapes. And very nice, she can cut it. If it were me, I probably would have just, ripped it with my hands, but cutting it is probably a cleaner and better way to do that. So very good. and she's going to kind of reshape that into a little circular shape. Again, about 1 inch thick. Beautiful. And then she'll reshape the other one, and I think we are about done with round 1. So what you're going to do now, take your circular shapes, and you're going to place them on the left baking sheet that you made. Now, the reason that it's important to keep track of which ones go where is because, remember, each set is going to be a little bit different, and we want to be able to keep track of, what did we do to these ones that, and so when we look at the final product, we'll be able to say, these ones that didn't have any baking soda were, whatever we end up finding at the end. But I think we're in good shape. So what you can do now, Crissy, is you can take your baking sheet and just set it in your refrigerator. So basically now we're going to do almost the exact same thing 2 more times. So what we need to do is get our ingredients back and get our mixing bowl ready to mix up another batch. So again, in case you, didn't etch it into your memory the first time, we need 2/3 of a cup of flour, which if your measuring cup doesn't have 2/3 mark, 2/3 is the same as 1/3 2 times, basically. Not basically, it is exactly the same. So yeah, 2/3 of a cup of flour, or 2 1/3 cups of flour. Okay, we got our flour. Next, we need 1 teaspoon of sugar. We still need that 1/3 teaspoon of salt, and you probably didn't get a 1/3 teaspoon since last time we needed one. So again, we're going to have to kind of estimate with the 1/4 plus a little bit. Okay, good. This time, what's going to be different is we are also going to add 1 teaspoon of baking powder. And so Crissy is preparing 1 teaspoon of baking powder as we speak.
Ooh, my baking powder has this awesome lip on it that I can level out.
Very nice.
So I'm going to do 2 half
That is
spoons.
absolutely
Is that okay?
fine. 2 1/2 is the same as 1 whole. Fractions.
So
They're beautiful.
do I go ahead and mix all these up?
Yeah, so same thing, mix them up a little bit, and then we're going to need to add our butter, just like we did before. So again, that was 2 tablespoons of butter. And it looks like our round 2 dough is coming along pretty well. And so we're ready to, yes, put some flour on our baking, or I guess not, on our mixing board there. And scoop out our dough. Very good. And again, kind of smoosh it together a little bit, where it's kind of sticking together as one big glob, and then we're going to do our fold and turn movement
Method?
earlier. Yes. We'll get our baking sheet, and this time we're going to put these 2 in the middle so we can keep track of where, round 2 is going to be the ones right there in the middle, and that will make it easy to tell which one's which.
And I only have a small baking pan, so I might grab my other one and do the same thing.
Sure, that would work fine.
Okay.
That's fine, yeah. But the important thing is to make sure we keep track of what's on what side and what's on the other side, right? So it looks like for what we have so far in your small baking pan, we have trial 1 is on the left, trial 2 is on the right, and then your third baking pan will just have, sorry, your second pan will have trial 3. So we're going to do the same, mix everything up again, and so that is 2/3 of a cup of flour. Remember, we're leveling it off so we don't get too much flour. 1 teaspoon of sugar, and our sort of 1/3 teaspoon of salt, which is really a 1/4 teaspoon of salt plus a little bit more, but that'll be okay. We'll just have to guess, which is what we're doing. And again, the salt is, as long as we get it close, we'll be fine. Okay, so we got all of those, but we want to add even more baking soda this time. So we're going to do 2 teaspoons of baking powder.
Okay, so that's going to be 4 half teaspoons.
4 half teaspoons, exactly. Very good. And we're going to mix that together. And then we need to add our 2 more tablespoons of butter. And remember to chop it up. Okay, so we are finishing up with round 3 here.
This one definitely feels different.
Interesting observation. We'll take note of that. So how would you describe the way it feels different, or what feels different about it?
It's almost like more like smushy and like stays. It's seemingly like staying together better, but it's also like whenever I try to like flatten it out, it kind of
doesn't want to flatten out.
Yeah, it kind of bounces back up.
Interesting.
So that's
well, that's a good observation. And maybe as we talk about what baking powder is, maybe that will help us understand why.
Why?
But first, we're not ready for that yet because we need to put our last round here in a different baking pan here. If you have a big baking pan, you can put them all together. Just keep track of which trial is which. But Crissy's her baking pan was kind of small, so we've got this a third one for round 3. And you did butter that one, correct,
I
Crissy?
did butter that one.
Very good. Okay, so we are now ready to put our baked items in the oven and let them bake. And so our oven should be set at 425. If you started it heating up when we started cooking, then it should definitely be warmed up by now. So what we can do is go ahead and put our little trays in the oven, and we are going to set a timer for 12 minutes. So you should set your own timer because we might not, you don't want to just rely on the video in case you need to pause the video, or if we edit some things around in the video, make sure you have your own timer. So you want to do this for 12 minutes, and our baked items should be a nice golden brown when they are ready. And that should, like I said, take about 12 minutes.
I'm going to go put these in and set a timer.
Perfect. Okay, so let's talk a little bit about the science that's happening when we cook something with baking powder. And if you're like me, you might have always been wondering what's the difference between baking powder and baking soda. So as it turns out, baking powder actually has baking soda in it. So baking powder is a mix of a base, which in this case is baking soda, a weak acid, and a starch. And you might be thinking, oh my gosh, baking powder has acid in it and we're eating it. That can't be healthy for us, right? Well, it turns out that we actually eat a lot of different weak acids and they're perfectly fine. In fact, they're good for us. There's a lot of things that are good for you as long as you don't have like crazy amounts of it. And weak acids are the same, just like water is good for you, right? But if you were to try to drink like 3 bajillion gallons, it probably would not be great. So we'll take that in consideration here. But just some other examples of weak acids that you might have eaten before are lemon juice, has citric acid in it. Soda, or Coke, Sprite, Pepsi, anything like that, they all have carbonic acid in them. We'll talk more about carbonic acid in a minute. Cheese has sorbic acid in it. Milk has lactic acid in it. And vinegar has acetic acid in it. So those are all things that you've probably eaten before, and they all have acid in them. So it's not a big deal, right? Okay, so let's talk about what is baking soda. Baking soda, the chemical name is sodium bicarbonate. And so from that name, we can tell that we've got sodium, that's Na, hydrogen is H, C for carbon, O for oxygen. We don't need to worry too much about any of that for today, but just so that we know what we're talking about here, we have the sodium and the bicarbonate, and our sodium bicarbonate atom or molecule would look kind of like that. So then, well, what about the other stuff? So we said we have a weak acid. Most baking soda is going to use phosphoric acid, and phosphoric acid looks kind of like this molecule over here. And it's going to have some hydrogen, some phosphorus, and some oxygen. We're not super familiar, though, with phosphoric acid. We don't really use it in any other situation that we're familiar with. But as far as the chemistry is concerned, it's pretty similar to something that you are familiar with, which is acetic acid, which we can find in vinegar. And so acetic acid is a little bit different formula here, CH3COOH, or we could write that a different way, it means the same thing over here. But the key thing here is that we've got some hydrogens that can fall off, and we'll see why that's important when we look at our reaction. So we look here, this is our baking soda, this is our vinegar, and you might have done this experiment before, right? So when you mix baking soda and vinegar together, we know that they fizz up and make lots of bubbles, and and that's exciting. You make a volcano, cool, right? Okay, so what happens is when you mix the baking soda and the vinegar, they kind of rearrange the molecules a little bit. You can see the Na came off the baking soda, joins up with the other part over here, and we end up with this stuff, H2CO3. We'll talk more about that in a minute, but just so we can see here, baking soda plus vinegar, we're going to make carbonic acid, which is in soda, we already knew that, and sodium acetate, which could be used to give salt and vinegar flavor to potato chips, or we use it in little reusable heating pads because it actually gives off a lot of heat. So that's a cool fact there. Like I just said, that is in soda, so that actually is what makes your soda fizzy. And so we're going to need to talk about our second reaction here. So we have our carbonic acid, and carbonic acid is not very stable, so it's not going to stay as carbonic acid for very long. And it's pretty quickly going to turn into two things that we might recognize here: CO2, which is carbon dioxide, and H2O, which is water. So yeah, these are two things that you've probably at least heard of before. You've probably drank a lot of water in your life, and you've probably breathed in and breathed out a lot of carbon dioxide. So familiar things that we've seen before, right? But here's why this is important. When you have a soda or something, those CO2 bubbles form gas. They make little bubbles all around in your soda, right? And that's what you're seeing when you unscrew the top of your soda bottle, and you see all the bubbles rise up to the top. And those bubbles are trapped in the surroundings, and so they make a foam, and that's what takes up all the space and gives you a volcano if you're trying to do that experiment, or makes your soda overflow if you shook it up too much. But in the case of our baking, they're going to take up space inside of our little baked good and make it kind of expand up a little bit. So if we think about this, we know the first trial we didn't put any baking powder. So no baking powder means no baking soda, means no carbon dioxide, right? So we can probably guess that the first ones might not rise very much because they're not going to expand. The second one, we put a little baking powder. So that means a little bit of baking soda, which means this reaction is going to happen a little bit. So they might expand a little bit. And then round three, we put a lot of baking powder. So you can probably guess a lot of baking powder means a lot of baking soda, means a lot of carbon dioxide, means a lot of bubbles, means it's going to expand a lot, and it's going to take up a lot of space, okay? So, and that's also when those bubbles pop, that's what you're hearing when you have your soda. The last ingredient was starch, which is basically a carbohydrate, and long story short, it's just a long chain of sugar molecules. And all it really does in the baking powder is it keeps the acid and the base from reacting until we're ready. So it's just kind of stabilizer. Now, the last thing that I wanted to talk about, though, is something that Crissy mentioned when she was making our biscuits for round three, making our baked items for round three. She noticed that the third round was much poofier, and it was almost like expanding more as she was working on it. And what might have been going on, we'll have to check and see if Crissy had single-acting or double-acting baking powder. Okay, so double-acting baking powder actually has two acids, and so it acts twice. That's why it gets the name, right? And so it acts once before baking and once while baking. And so maybe powder in that third one, maybe if it was double-acting, it already had started to react and produce some CO2 bubbles to make our little baked item expand more. But we'll have to check and see with Crissy. As a side note, in bread we put yeast, and that is doing the same exact thing. It's eating sugar and it's breaking that sugar down into CO2. You might think, ooh, we're eating a fungus, but it's normal, right? Bread is normal thing, not a big deal. And so yeah, so yeast is what makes bread rise. Pretty cool stuff. All right, so we got our biscuits out of the oven. Make sure you're using an oven mitt or something to keep your hands from getting burned when you're picking them out, because they will be hot. 425 degrees to be exact, right? So we've got our biscuits here. That's what they turned out to be, looks like, right? Biscuits. Real test is to eat them, right?
Do I have to eat number one?
Well, I can't make you do anything, but for science, I think we really need to know. You don't have to eat the whole thing, but you could just take a bite and see.
Okay. If it's in the name of science.
Which raises a good question. Usually we don't like to taste or eat our science experiments, right? That's kind of one of the most important rules as a scientist. But sometimes when you are experimenting and doing science of cooking, well, that's like the only test that really matters, right? Is how does it taste? And so, we know what we put in, and we use only things that are healthy and will not hurt us, and will even, taste good and give us a good little snack here, right? So usually don't eat your science experiment, but in this case, it'll be fine. So Chris, with all of the world's scientists waiting and, watching and wonder to see what you find, take a bite out of one of those trial one biscuits and tell us what you think.
Not as bad as I was expecting.
So not as bad as you were expecting. Can you describe kind of the texture of eating it and how it tastes?
It's dry. It kind of tastes like a cracker.
Okay, so it's more of a cracker than a biscuit or a cookie or something like that. Bread.
Definitely dry.
Definitely dry.
There's nothing very fluffy about it. It's definitely not inedible.
Okay, great. Well, what do you think? Should we go to number 2 or should we go to number 3 next?
Let's go to number 3. Let's go opposite ends.
Okay, so we did number 1. Let's try number 3.
Okay. At first it was okay.
But then
not so good.
Okay, so can you describe what's not so good about it?
It has a taste of well, I know it's the baking powder.
Right. That was the one that we had locked in.
Yep. How do you describe the taste of baking powder?
I'm not sure. That's one realm that technology has not. I can't taste it from here, right? I can only.
Like at first it's okay, and then it adjusts to your taste buds, and it's like, whoa, there's something.
Is it bitter?
It's bitter. That's exactly.
Okay. But between 1 and 3, which
Definitely
do you prefer? Number 1. Okay, interesting. I had thought that maybe 1 would be kind of like you said, almost inedible, just like I was thinking like a board, like a piece of wood, just like you wouldn't be able to bite into it. But
it's very solid. Don't get me wrong. Like I don't.
Yeah.
Wait a minute. Where's the?
Yeah. But the flavor you said was not bad.
The flavor's not bad.
Well, there's only one test that remains, and that is round 2.
I'm excited about this one. Here I go. That's a biscuit.
All right. So did we succeed with round 2?
We definitely did.
Okay, good.
I took a really big bite.
Good. Yeah, I noticed that your bites on round 1 and round 2 were a little timid. Not that I blame you, but so round 2 was like the correct ratio based on the recipe. We don't really like to use the term correct, but that's the one that was from the recipe.
Mm-hmm.
And then round 1 was no baking soda, and then round 3 was no baking powder. Round 3 was twice as much baking powder as the recipe called for. So that kind of shows us what the role of the baking powder is. Is it we like we said, we can definitely tell that it fluffed it up and it poofed it out and made it take up more space. But one side effect of poofing out too much is that you have a bunch of leftover baking powder in there, and you get the maybe more carbonic acid than you really wanted, which means you get more of the CO2 than you really wanted. So that's a good observation that we were able to notice there. And remember, we only changed one thing. We changed how much baking powder we put in. If we had said, okay, we're going to put 3/4 of a cup of milk in this one, and 1/4 of a cup of milk in the next one, and also change the baking powder, and also change the amount of sugar, they would be all over the place, and we couldn't really say, well, the baking powder does this or the milk does that, because there's too much going on, and it's hard to say. So, Crissy, what could we do if I wanted to know, well, how does the amount of milk affect the recipe? How could I do this experiment again in a little bit different way?
I think that if you wanted to do that, then you would have to change your one variable. So instead of changing the amount of baking soda and the amount, or baking powder and the amount of milk, you would keep the same amount of baking powder and then only change the milk. And I think you could do that with
we could do that with the amount of milk,
right?
We could do it with the amount of sugar, we could do it with the amount of salt, we could do it with the amount of butter, we could do it with the amount of flour. We could also do it with how long we cooked it, right?
Mm-hmm.
So we might try one where you only cook it for 6 minutes, and then you cook it for 12, and then you cook it for 18 minutes or something like that. Now, we could probably predict pretty well what the results of that experiment would be, and we'd probably end up with, some biscuits and some burnt biscuits, which, would not be very exciting.
Well, thank you so much, Junie, or Mr. Shober, sorry, so much for coming and visiting with us and teaching us an amazing science experiment in the kitchen. And I just want to challenge all of y'all after your experiment to maybe share with your parents, maybe with a sibling, try it out and see what as well. So if you do the experiment, make sure to take a picture of it and tag us on Instagram or Facebook.
And let us know how your biscuits turned out.
Yes, let us know how they turned out. We want to know. So thank you so much, and we will see you next time. Bye.